Dear students, welcome to mathematics online classes. In the last class, we have solved up to problem number 5 in the exercise 9.4. Now, problem number 6 onwards. Problem number 6, it is a special size. We need to find out Sn here. Sum of first n terms we have to find. For that, An is equal to, what is An? Nth term of this series, we will find like nth term of first terms. What are those? 3, 6, 9, so on, which is multiplied with nth term of second terms 8, 11, 14, 8, 11, 14, so on. Okay, this is in AP with A is equal to 3 and a common difference D is equal to A2 minus A1 means 6 minus 3, that is also 3. And here this one is also in arithmetic progression with first term A is equal to 8 and common difference D is equal to 11 minus 8, 3. I will use the formula here using An is equal to A plus n minus 1 into D. Now I have An is equal to A is 3 plus number of terms are n into common difference is 3, which is multiplied with 8 plus n minus 1 into 3. This is equal to 3 plus 3n into 3n minus 3 multiplied with 8 plus 3n minus 3. This is plus 3 minus 3 get cancelled, 3n into 3n plus 5. Okay, 3n will get multiplied with these two. 3n into 3n is 9n square plus 3n into 5, 15n. We got nth term An is equal to, then Ak is equal to 9 into k square plus 15k. Kth term we got. Finding the Sn, sum of n terms using summation. Summation of Ak, where k varies from 1 to n is equal to, we have summation of 9k square plus 15k, where k varies from 1 to n. This can be written as 9 into summation of k square, where k varies from 1 to n, plus 15 into summation of k, where k varies from 1 to n. 9 as it is. What is summation of k square? Summation of k square is sum of squares of first n natural numbers. We can write it as this formula we know, n into n plus 1 into 2n plus 1 divided by 6 plus 15 into n plus 1 by 2, because it is sum of first n natural numbers formula. There is a common factor among these two. 3 3s are 3 2s are. Now common among these two is 3 into n plus 1 by 2 is common, because this 15 can be written as 3 into 5. 3 is also common. Now what are the remaining here? From the first term 3 is outside, n into n plus 1 by 2 is outside, 2n plus 1 remains. From the second term n into n plus 1 by 2 and also among this 3 is outside, 5 remains here. 3 into n plus 1, 2n plus 6 divided by 2. 3 into n plus 1, 2 is common, into n plus 3 whole divided by 2. 2 get cancels. 3 into n plus 1 into n plus 3 is the final answer. This is about question number 6 in the exercise 9.4. Now we will go to the next question, that is question number 7. Question number 7, it is given that 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on. Now here you observe first term is 1 square, second term is 1 square plus 2 square, third term is 1 square plus 2 square plus 3 square. In the same way, what will be the nth term? Nth term itself is 1 square plus 2 square plus 3 square plus so on up to n square. This is nth term, an is equal to. Now we will find out Sn. Okay, an itself is sum of squares of first n natural numbers. First term is 1 square, second term is sum of squares of 2 natural numbers, third term is sum of squares of first 3 natural numbers, fourth term is sum of squares of first 4 natural numbers. In the same way, nth term is sum of squares of first n natural numbers. Okay, this formula we know, it is directly n into n plus 1 into 2n plus 1 by 6. This by 6 I will write outside. N into n plus 1 I am multiplying with 2n plus 1, n into 2n, 2n square, n into 1, n, 1 into 2n, 2n plus 1. 1 by 6 into n into 2n square plus 3n plus 1. 1 by 6 into n multiplies with these two, 2n cube plus 3n square plus n. Okay, this is what an. Ak is nothing but 1 by 6 into 2k cube plus 3k square plus k. Now we will use the Sn formula. Sn is equal to summation of ak, where k varies from 1 to n. Summation of ak is 1 by 6 into 2k cube plus 3k square plus k, where k varies from 1 to n. Okay, Sn is equal to 1 by 6 is a constant multiple. I can write it out of the integral, out of the summation. 1 by 6 into first one, summation of 2k cube is nothing but 2 into summation of k cube, where k varies from 1 to n, plus of next is 3 into summation of k square, where k varies from 1 to n, plus next summation of k, where k varies from 1 to n. 1 by 6 let it be outside, 2 as it is. Summation of k cube is sum of cubes of first n natural numbers, can be written as n square into n plus 1 whole square divided by 4, plus of 3 into summation of k square is n into n plus 1 into 2n plus 1 whole divided by 6, plus of summation of k is n into n plus 1 by 2. You cancel the see 2 and 4 have the common factor, 2 1 za, 2 2 za, 3 1 za, 3 2 za, 1 by 6 as it is. From all these 3 terms, what is common? Common term is n into n plus 1 by 2. Now n into n plus 1 is remaining from the first term, 2n plus 1 from the second term, and 1 from the third term. This is n into n plus 1 by 6 2 za 12, which is multiplied with n into n, n square plus n, 2n plus 1 plus 1 2. This is n into n plus 1 into n square plus 3n plus 2 whole divided by 12. We can simplify it further. N into n plus 1 into this n square plus 3n plus 2, it is a quadratic equation. You can split it like n square plus n plus 2n plus 2 whole divided by 12. N into n plus 1 into, from first two terms n is common, into n plus 1, plus next terms 2 is common, into n plus 1 whole divided by 12. Okay. Now n into n plus 1 into, from these two terms n plus 1 is common, into n plus 2 whole divided by 12. N into n plus 1 into n plus 1, this is nothing but n plus 1 whole square, which is multiplied with n plus 2 whole divided by 12. This is the Sn is equal to sum of first n terms, Sn is equal to that one for this special series. This is about problem number 7. Now problem number 8 onwards. Problem number 8 onwards, directly nth term is given to us. We no need to find out nth term here. It says find the sum to n terms, find the sum to n terms of the series whose nth term is given by, whose nth term is given by, means whose nth term is already given to us. Directly we need to find out sum of n terms, means Sn. Let me take the question number 8. It says n into n plus 1 into n plus 4. Solving the problem, this is an. An is equal to n into n plus 1 into n plus 4. Now an is equal to n into, you multiply this, n into n, n square, n into 4, 4n, 1 into n, n, 1 into 4, 4. An is equal to n into n square plus 5n plus 4. This n also multiplies with all three terms. An is equal to n cube plus 5n square plus 4n. What is ak then? Then ak is k cube plus 5k square plus 4k. Using the Sn formula, Sn is equal to summation of ak, where k varies from 1 to n. Summation of ak is k cube plus 5k square plus 4k, where k varies from 1 to n. This can be written as summation of k cube, where k varies from 1 to n, plus of 5 into summation of k square, where k varies from 1 to n, plus 4 into summation of k, where k varies from 1 to n. Sn is equal to summation of k cube formula, n square into n plus 1 whole square divided by 4, plus of 5 into summation of k square is n into n plus 1 into 2n plus 1 divided by 6, plus of summation of k, 4 as it is, summation of k is n into n plus 1 divided by 2. Okay, here 2 ones are, 2 twos are, I can cancel. Take the common terms from all these. What is common here? N into n plus 1 is common. Now remaining n into n plus 1 by 4 from the first term. From the second term, 5 into 2n plus 1 by 6, and from the third term only 2 remains over there. Take the take the LCM, 4 and 6. LCM is 12, we can take 12. 4 3s are, this is 3n into n plus 1, and 6 2s are 12, means 2 into 5, 10 into 2n plus 1 plus 12 is there, 12 into 2, 24. n into n plus 1 into 3n into n, 3n square, 3n into 1, 3n, 10 into 2n, 20n, 10 into 1, 10 plus 24, whole divided by 12. n into n plus 1 into 3n square plus this is 23n, this is 34, whole divided by 12. You can leave it here. According to the scheme of evaluation, even if you write up to here you will get the full mark, but better you simplify up to this. If possible, you simplify this quadratic equation also, or better you leave it here, you will get the full mark. This is about question number 8. Now Going to question number 9. Question number 9 also heading it will be same, that is finding the sum to n terms of the series whose nth term is given. Question number 9 is n square plus 2 raised to n. N square plus 2 raised to n. Okay, this is an. An is equal to n square plus 2 raised to n. Directly we will find ak. Ak is equal to k square plus 2 raised to k. Sn is equal to formula summation of ak where k varies from 1 to n. Summation of ak is k square plus 2 raised to k where k varies from 1 to n. What is this? This is summation of k square where k varies from 1 to n is the first term, and next is summation of 2 raised to k where k varies from 1 to n is the second term. What is the summation of k square? This is sum of squares of first n natural numbers. We know that formula. That one we will put directly as n into n plus 1 into 2n plus 1 whole divided by 6 plus of, what is the summation of 2 raised to k? Summation of 2 raised to k equal to, we have not derived any formula, but what does it mean actually? It means 2 raised to 1 plus 2 raised to 2, 2 raised to 3, so on up to where? Up to 2 raised to n it is. This is the meaning of that. Now you see, this series is a geometric series. It is in geometric progression. Okay. With first term a is equal to 2, common ratio r is equal to 2 square by 2, 1 time 2 to get cancel r. How many terms are there? N terms are there. And what we are finding here? We are finding sum of all these terms. As we are finding sum of all these terms, we will use Sn formula. What is that? Using Sn is equal to, r value is greater than 1. So, we will use the formula a into r raised to n minus 1 by r minus 1. Now, that Sn is equal to, this Sn is equal to, first term we can't do anything, it is final n into n plus 1 into 2n plus 1 by 6 plus of, next, this is nothing but using the Sn formula we can take the sum of all those. A is 2 into r is 2, how many terms are there? N terms are there, minus 1 divided by 2 minus 1. 2 minus 1 is nothing but 1. N into n plus 1 into 2n plus 1 whole divided by 6 plus 2 into 2 raised to n minus 1 is the final answer. This is about question number 9 in the exercise 9.4. Now, we will go to the last problem of the exercise, that is problem number 10. Problem number 10, given that 2n minus 1 whole square, 2n minus 1 whole square. Okay, this is an. An is equal to 2n minus 1 whole square. Ak, directly we can't take the summation here, that's why what you do, you expand this. It is in the form a minus b whole square. What is a minus b whole square is equal to formula? A minus b whole square is equal to, we know it is a square plus b square minus 2ab. I am using that formula. A means 2n here, b means 1. 2n whole square plus 1 square minus 2 into 2n into 1. This is 4n square plus 1 minus 4n. Let me rewrite it. 4n square minus 4n plus 1 an is equal to. Then what is ak equal to? Ak is equal to 4k square minus 4k plus 1. Fine. Then Sn formula. Sn is equal to summation of ak where k varies from 1 to n. Write it. Summation of ak is 4k square minus 4k plus 1 where k varies from 1 to n. This is 4 into summation of k square where k varies from 1 to n is the first term minus 4 into summation of k where k varies from 1 to n is the second term plus summation of 1 where k varies from 1 to n is the third term. Sn is equal to 4 into what is summation of k square? Sum of squares of first n natural numbers formula, that is n into n plus 1 into 2n plus 1 whole divided by 6 minus 4 into summation of k is nothing but n into n plus 1 by 2 plus of summation of 1. Summation of 1 means k is taking the different values, but in each case it is 1 only. 1 plus 1 plus 1 plus 1 plus 1. How many times it is getting added? N times it is getting added. Therefore, summation of 1 where k varies from 1 to n is n. 4 and 6 have a common factor. 2 2s are, 2 3s are, 2 1s are, 2 2s are. From all these three terms, what is common? N is common here. Take n outside. N into here remaining 2 into n plus 1 into 2n plus 1 divided by 3 minus of, from this n is already outside, 2 into n plus 1, n is outside means 1 remains from the third term. Okay. N into, take the LCM, LCM is 3 here, 2 into n plus 1 into 2n plus 1 minus of, here 1 is there means 6 it becomes, 3 into 2 6, 6 into n plus 1 plus 1 is there here means it become 3. N into, you multiply this 2, let it be outside, n into 2n, 2n square, n into 1, n, 1 into 2n, 2n, 1 into 1, 1, minus 6n, minus 6 into 1, minus 6 plus 3 whole divided by 3. N into, let me write one more step here, 2 into 2n square plus 3n plus 1 minus 6n minus 3 whole divided by 3. N into 2 into 2n square is 4n square, 2 into 3 6n plus 2 minus 6n minus 3 whole divided by 3. This is equal to n into 4n square plus 6n minus 6n get cancel, plus 2 minus 3 is minus 1 whole divided by 3. This can be written as n into this 2n square is 4n square is there, no, can be written as 2n whole square minus 1 is there, can be written as minus 1 square whole divided by 3. Why I am writing like this? It is in the form a square minus b square. What is a square minus b square equal to? Formula a plus b into a minus b. Okay, n into 2n plus 1 into 2n minus 1, where a is 2n, b is 1 whole divided by 3. This is the Sn, sum of n terms of this special series whose nth term is 2n minus 1 whole square. Dear students, with this problem we are finished with the chapter sequences and series. Please revise all the videos which we have uploaded for your well understanding and knowing the concepts well. Thank you.